Kirkle Math. Hello and welcome back to 6.1 Equivalent Ratios, Part 2B. If you were not with us when we went over these examples previously and vocabulary words about equivalent ratios, please find video Part 2A. Otherwise, join us here. We're going to start looking at some other ways to make equivalent ratios. So this right here is called a tape diagram. And it's because we use these little kind of chunks, they almost look like tape. And we're going to use that to answer and solve this problem here using equivalent ratios and a tape diagram. Audrey and Megan are decorating for a birthday party. Audrey hangs 4 streamers in the same amount of time that Megan hangs 6. If Audrey hangs 14 streamers, then how many streamers can Megan hang? Determine the scale factor. So we're going to pretend that these are little streamers that we're hanging. So Audrey had 4 for every 6 that Megan can hang. Now, if Audrey hung 12 streamers instead, so let's instead say that this whole thing represents 12 instead, then we want to know how many would Megan hang. Well, we know that the ratio is 4 to 6, so if Audrey hangs 12, then how many would that be for each of these little chunks of time, for each of these 4 streamer chunks? Well, what we're going to do is 12 divided by 4, and that's going to get me 3. So each of these represents 3 streamers, okay? Because they are equivalent, because we made them equal, and because we had 4 equal pieces for every 6 equal pieces, I'm going to directly connect these numbers downwards into Megan because they're the same size. So that means that for Megan's, these are also 3 chunk pieces. We're then going to look at the total here, and that's going to be 3, 6, 9, 12, 13, 14, 15, 16, 17, 18. So this is 18 streamers. And that's our answer. Megan can hang 18 streamers in the time that Audrey hangs 14 streamers. Now that is one way to draw a picture and kind of see a nice visual connecting these equivalent ratios. However, if you do not like drawing, or you can do the math in your head faster, I highly recommend you do this: bar, equal sign, bar. And it's basically using equivalent ratios. What I'm going to do is on my left is going to be my current ratio. And on the right is going to be my future prediction. Okay. On my left, I'm going to compare Audrey's streamers with Megan's streamers. And on the right, I'm still going to compare Audrey's streamers to Megan's streamers, just in the future. So currently, Audrey hangs 4 for every 6 Megan hangs. And in the future, Audrey's going to hang 12 to every I don't know. Because again, this is a different way we're doing it, so we're going to pretend we don't know the answer yet. Just like we did on the last video, if you were here for that, I'm going to ask myself, 4 times what is 12? Well, that's 3. So I need to do 6 times 3 to get my answer. 6 times 3 is 18. And that is how I use equivalent ratios to solve a problem like this. So we can use tape diagrams or equivalent ratios. Let's look at another one. Here we're going to use another form of tape diagram, which is just going to be using number lines though. So we've got Sally's summer punch recipe is a combination of lemonade and fruit punch. Sally uses 3 cups of lemonade for every 4 cups of fruit punch. In order to make a batch for the 4th of July party, Sally uses 21 cups of lemonade. How many cups of fruit punch will Sally use? So we have 3 cups of lemonade for every 4 cups of fruit punch. We know that Sally uses 21 cups of lemonade for her party. And we need to figure out how many cups of fruit punch that will be. Well, because we know that Sally is using lemonade in 3-cup increments, I need to divide this number line into 3-cup chunks. So what I need to do is think 21 divided by 3 makes what? 7. So I'm going to divide this number line into 7 equal pieces. 1, 2, 3, 4, 5, 6, 7. 3 cups, 6, 9, 12, 15, 18, 21. Now, again, because the top part is equal, the bottom part needs to be equal too. So we're also going to divide this into 7 equal pieces, because you can almost think of this as I'm going to pour 7 times into this fruit punch. And every time I pour, I'm going to pour 3 cups of lemonade and 4 cups of fruit punch. 3 cups of lemonade, 4 cups of fruit punch, right? Every time I pour, and I'm going to do 7 pours. However, I'm not going to skip count by 3s like I did lemonade. I'm going to skip count by 4s because that's how many cups of fruit punch. 4, 8, 12, 16, 20, 24, 28. And that's my answer. It's going to be 28 cups of fruit punch. All right, so once again, if you don't want to draw out this, or if you think you can do it in your head a little bit faster, we're going to draw bar equals bar. This is our current ratio. This is our future prediction. Okay? We are comparing lemonade to fruit punch. Lemonade to fruit punch. Currently, Sally uses 3 cups lemonade and 4 cups fruit punch. In the future, she's going to use 21 cups lemonade, and we don't know how many cups of fruit punch. 3 times what is 21? That's 7. So 4 times 7, excuse me, will get me my answer of 28. So again, 2 different ways to do it. You can pick which one makes the most sense. All right, here we go. We have a last set of examples. I'm going to mainly use the equivalent ratios, the bar equals bar, because we use this a lot in the future. You are absolutely welcome to use the tape diagram, but also because some of these are going to get a little complicated, and I think it makes sense to kind of set up our equivalent ratios, think about what I'm trying to compare to find my answer, and then fill in my numbers. And I'll show you what I mean here in a second. Oops. Come back. All right, so in this first one, it says use the pattern below to determine how many gray squares there would be if there are 15 white squares. So in order to solve the problem, I need to compare gray squares to white squares. Remember, this is my current ratio, and this is my future prediction. Currently, there are 1, 2, 3, 4 gray squares, and 1, 2, 3 white squares. In the future, there were going to be 15 white squares. How many gray squares will there be? 3 times 5 is 15. 4 times 5 will get me my answer, which is 20 gray squares. So these first ones are pretty simple. Let's do the next one. Mrs. Malone earns 2 hours of paid vacation for every 9 days she works. How many hours? How many hours of paid vacation will Mrs. Malone earn after working 81 days? So I can tell that to find my answer, I'm comparing my vacation time with my work time. Vacation and work. Currently, I get 2 hours of paid vacation for every 9 days that I work. If I work 81 days, how many hours of paid vacation? Same thing. 9 times 9 is 81. So 2 times 9 will get me my answer. That's 18 hours of vacation. Now this is where it gets a bit tricky. In this next one, we're comparing gold and red wrapping paper. We have a fundraiser. The ratio of gold sold to red is 5 to 8. If the school sells 78 rolls, how many were gold? So I'm going to take some notes off to the side. I've got 5 to 8 gold to red. The school sells 78 rolls. Is that one color or is that total? That's going to be total. And in the end, I want to know how many gold. So what I find interesting here is that my final ratio, in order to find my answer, I need to compare gold rolls of paper to total rolls sold. But in my original ratio here, I don't have a total. They don't give that to me. So I'm going to have to do a little bit of math to find my total. 5 gold plus 8 red equals 11 total rolls of paper. So I originally had 5 gold and 11 total. Oh wait, not 11. I totally did my math wrong. That's 13. 13, that makes more sense. Okay. In the future, we're going to sell 78 rolls, and we need to predict how many will be gold if the ratio stays the same. So we're going to figure out 13 times 78, or 13 times what makes 78. So I'm actually going to do some long division and do 78 divided by 13. And it turns out to be 13 times 5? No. 13 times 6? Yes. 6. So I'm going to do 5 times 6 to get my answer. There's going to be 30 rolls of gold paper. Okay. See how we had to do excuse me, we had a little bit of math in order to figure this out. And I had to think this last sentence is kind of the sentence that told me what I'm comparing. So let's try this again. There are a total of 30 puzzle pieces. 3 out of 5 are red. The remaining are black. How many are black? So 3 out of 5 are red. So 3 are red out of 5 total. The rest of them are black. How many would be black if 3 out of 5 were red and the rest are black? That would leave 2 left over. I subtracted. If I have 30 total puzzle pieces, I need to figure out how many black. So black, I know I need black, and they're giving me a total here. So I'm going to compare black puzzle pieces and total puzzle pieces. Currently, I have 2 black for every 5 total. So in the future, I'm going to have, I don't know how many black for every 30 total. 5 times 6 is 30. So 2 times 6 is going to be 12 black puzzle pieces. And then the last one. Jamal says that 18 to 12 and 3 to 4 are not equivalent ratios, but Margie says they are equivalent. Who is correct? So we need to figure out if 18 to 12 is equal to 3 to 4. Well, 3 times 6 makes 18. 4 times 6 does not make 12. I could also divide both of these by 6 and get 3 over 2. So I know that they're not equal. So Jamal is right. All right. And that was equivalent ratios. Join me next time to go over what a rate is.